The following podcast is sponsored by Structure Tech.
May is National Safety Month for decks. So everybody,
Yes.
Tessa, Reuben, let's hear it for safety and decks. Welcome everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulbrich alongside Tessa Murray and Reuben Saltzman. As always, your three-legged stool coming to you from the Northland, talking all things houses, details about houses, home inspections, and occasionally we dip our toes into the real estate market. But we don't have any intention of doing that today. We are going to continue to talk about technical stuff because we've just come out of like 4 or 5 conversations of market talk, and Reuben has told me he's just done with it. So he wanted to talk about decks. And May is National Safety Month for decks. So everybody,
Yes.
Tessa, Reuben, let's hear it for safety and decks specifically.
Yeah.
Ooh.
Good time to talk about decks.
No, in all seriousness, it feels like most decks were applied with, super glue, possibly flex steel or some other not very strong device to hold them up. And they were usually built by an uncle in 2 cases of beer. You ever run across that in your time inspecting, Reuben?
I've seen a lot of those decks. Oh my goodness.
Were there ever beer labels affixed to the bottom of like one of the joists just to prove how many bottles were consumed during construction?
I haven't seen that yet, but it sounds like a great idea.
I recall when I was a young handyman and I thought I knew how to build things. My first project was a deck, and it was on a roof of a 412 slope on a shed roof. So this building had an apartment above it, and then there was this entryway up like the back to get to an old brick building. Nobody can see me using my hands to try to explain it, so it's a really good pod. But nevertheless, there was this addition, and it had this little sloping roof, and then there was a door that came out to that roof in case anybody ever needed to go fix anything. And I thought, wow, this would be a great place for a deck. So I built this very heavy deck on top of hand frame rafters that are probably 2x4s. I don't know. That thing is still there today, some 35 years later. I probably wouldn't walk on it anymore, but
Oh my gosh.
I had no idea about safety. So May would have been a good thing for me to review deck safety before I built this. But nevertheless, nobody cares about my stories. Let's talk about your experience, Reuben, and you, Tessa. When you were out in the field, what was the most common thing you saw on decks that just made you scratch your head?
Gosh, like you said, I think it's a lot of people, tackle fixing a deck or building a deck on their own. They think, oh, I can do this. It's simple. Probably the most common thing is just, improper like nails and brackets being used for support or improper ledger board attachment to a house. But like Reuben said, there's so many places for it to go wrong. And I think I've seen pretty much every potential crazy thing out there with decks.
So Reuben, can you give us some anatomy of a deck for anybody who doesn't completely understand what a ledger board attachment is?
Sure. Well, for most decks, there's going to be 2 main places where the deck is supported. And, there's always exceptions to this, but the most common way to do it is you attach one side of your deck to the house and the other side is supported with a bunch of posts and then a bunch of big pieces of wood that are fastened together. I call them a beam. I know that purists out there are going to say, well, it's not technically a beam. Yeah, shut up. I know. I'm calling it a beam anyway.
What would they call it if it's not a beam?
I don't know. I can never remember. It's like a built up member or something like that, or a double 2x10 or something like that. I don't know.
Well, we're technical, but we're not that technical.
Yeah,
so.
I'm calling it a beam.
Beam works.
So it's supported on one side by a beam and posts, and it's supported on the other side at the house. And where it attaches to the house, it's usually going to be a big piece of dimensional lumber, like a 2x10 or a 2x8 or maybe a 2x12 if it's monster. And that thing is called the ledger board. And it attaches to the house. That's one of the most critical points of the deck, is to make sure it's properly supported there. When you look into deck failures, there's basically 2 ways that decks fail and that people get injured. Number 1, it comes loose from the house right at the ledger board. Number 2, the guards fail or guard rail. For this podcast, we'll probably just call them guards. Everybody likes to say guardrail, but the technical name, and I'm just in the habit of saying it, is a guard. That's that thing that keeps you from falling over the edge of the deck. Those are kind of the 2 places where people get hurt.
How high up do you need a guard? At what point is it required?
Once you've got a fall of 30 inches or more, you need to have a guard. And if you're pretty much anywhere in the country other than Minnesota, the way you measure that 30 inches is you look at the deck floor and you go 3 feet out. And anywhere within that 3 feet, if it's more than 30 inches to the ground, you need a guard. And it means that if you're like on the edge of a cliff, you can't just measure straight down from the edge of your deck and say, oh yeah, it's 29 inches here. And then it drops off this steep cliff. Logic would tell you, you should still have a guard there. It's not safe. You should measure at least 3 feet out because that's where somebody's going to land. Now in Minnesota, it's different. We don't have that rule. It's in the national model codes. The International Residential Code says that's what you need to do. But in Minnesota, we have amended that national code. And all you need to have there is you measure straight down. Why? I don't know. I've asked, I have asked the code officials in Minnesota, a few of the bigwigs at the state, why is this? And one answer I got was that this is supposed to be common sense and people should just know that. And I guess my rebuttal would be, well, then why the heck would we remove it from the code? I just recently asked that question to someone teaching a class to licensed contractors in Minnesota. And his answer was that the code had waffled on that a few times where it was required, it wasn't, it was. I don't know all of that. I don't recall it changing in the past. Maybe it did, but he said, we're tired of it changing, so we just took it out. And still, that doesn't make any sense to me, but maybe they know something I don't. So that's a long-winded answer, Bill. You need it when you got more than a 30-inch drop-off, and the guard itself needs to be at least 3 feet high. I was getting ahead of myself with that 3 foot. And it needs to be strong too. If as long as we're talking about guards, Tessa, what's the requirement for strength? I'm quizzing you.
Is it 200 pounds of force?
You know it.
All right. Ding, ding, ding.
Yeah. When I was first...
You taught me well, Reuben. I'm glad I didn't get that wrong. That would have been embarrassing.
You're good. When I was first blogging about this, I was looking into the requirements and, how do you figure out 200 pounds? And there is no standard. So it's just got to be, does this type of construction get us to 200 pounds? And I was kind of curious, what does 200 pounds feel like? And I ended up just getting a bathroom scale, one of those old fashioned ones with the dial on there. And I got nice and low and a deck guard and I pushed on it. And this was a good deck. To get 200 pounds, it's like, I got to get low. You got to get your gravity really low and you really got to push. And I could barely get the needle to 200 pounds, but I couldn't keep it there. I kind of had to put my shoulder into it, like almost check it to get to 200. So that is a ton of weight. And it might seem like this is excessive. Like, why do we really need a guard that's that strong? But just picture a lot of people being outside, everybody having a party and everybody leaning up against that thing. Maybe even some of them drinking, possibly.
No.
No. And then picture that deck after 10 years, after water's been getting inside those connections, it's been weakening that wood, fasteners aren't as secure. Where are you going to be at now? Maybe now even the best built deck is going to be only capable of supporting 150 pounds. We need that. So I don't think the code is crazy in requiring 200 pounds. I think this is a good requirement for a new deck.
So is that the testing laboratories? Is that how they use it, an old scale, and they just push up against that thing? And
well, Bill, it's really not that different. There was a really good article that I found when I was blogging about this back in, 2010 or something like that. And they've taken it down since, and I didn't screen grab it. That's essentially what they did. They built it in a lab and they had this big piston or it was a hydraulic something or another, and they'd apply more and more pressure till it got to its failure point. And almost every time, I shouldn't say almost, every single time, it was not the newel post, the big 4x4 that would break. It was the connection between the post and the deck. And the old school way of doing that is that you would just notch about half of that 4x4 out, and then you'd put that up to the floor of the deck, and then you'd put a couple of nice bolts in there. And that would work pretty well when it was new. But over time, that connection would really weaken. And the biggest way it fails is the fasteners end up coming loose. And typically it's going to be fastened to the outside rim board of the deck. It's like, if you picture the way a deck is built, you have all the joists coming away from the end of the house. And on the ends of all those joists, you have another board that you nail onto the end of it. It's called your rim board, or we'll call it the rim board. It just kind of wraps around the edges of all the joists, and it's only nailed in place. There's no special fasteners. So when they put a lot of pressure on, sometimes that rim board itself will actually come out. So the posts will still be attached to the rim board, and the rim board will just rip off. It takes a lot of extra time to get that detail right, to make it really strong. It means you got to have your 4x4 full sized, and you need a bunch of fasteners going into something other than just the rim board. Ideally, you're going to have it going through a deck board, and you're going to fasten it both to a joist and the rim board. That's really the way to make a strong 4x4 for your guard.
Wow. There's a lot more there than I thought.
Yeah.
And that's just one component of a deck.
Yeah, that's just making sure that it's strong. Besides that, you also need to have the infill. You need to have balusters or something like that. I don't know, Tessa, you want to wax on those for a little while?
The balusters? Yeah, well, all the little vertical bars that go from the top of the guard to the bottom of the guard, and 4 inches apart or less, ideally. What else to say about those? I don't know. Lean on them, touch them, make sure they're not loose, rotted, falling out.
Yeah, my advice would be, if you're going to build a deck, don't do it where you have, and sorry to the manufacturers of these things, but don't use those metal ones that are supported at the top and bottom by 2x4s, where it's basically you drill a hole in your 2x4 and you stick the baluster into the 2x4. There is no way to prevent water from getting into every one of those holes. Water is going to follow down every one of those balusters, and it is going to rot the heck out of the bottom rail on your guard. Tessa?
Reuben, you seem a little passionate about this.
Yeah, I was wondering where this was going. Have this on one of your homes that you purchased?
It's on my home now. Tessa was actually at my house earlier today, along with a bunch of new inspectors on the team at Structure Tech. They inspected the heck out of my house today as a good training house, and they got to see my guards just falling apart. My guards are so severely rotted. I mean, one good kick and they're coming down. And that is a spring project. They're going to be replaced this year. I meant to do it last year, and we just did not get to it. Mine are embarrassingly bad.
Well, no rambunctious parties, Reuben, until you have that guard fixed.
I will not have any rambunctious parties until it's done. I promise.
I'd be curious to see how the rest of the house fared in the inspection. Any other deterioration or safety hazards that you care to share? Tessa just gave the lips are sealed.
Tess, you can be honest. Come on. What else did you guys find?
No. This is
Reuben's house is perfect. Reuben, actually, okay, well, not perfect, but Reuben, your house is in really good shape.
I'm a pretty good homeowner.
He is.
All
right. One detail I've noted on some decks, and oftentimes you'll see these on the sides of very tall buildings, are decks that have a guard that's made out of wire or some horizontal type of material. Yep. And they look super cool because you can kind of see through them. There's very little obstruction, so it helps with the view. And I've never really, I'm sure these exist on houses somewhere too, but yeah, it seems like that might be a little dicey if you're way up in the air and you've got something to climb up on. Like for child safety. So yeah, totally. Child safety. Yeah. Well, there actually used to be something in the building code. I think it was around like 2000 or 2003, something like that, where they prohibited having a guard that would create a ladder effect. You couldn't do that. But then once these steel cables started getting popular, I think the manufacturers or builders or somebody started putting pressure on the code officials, and that section actually got removed from the code. So it's been allowable to have that design for, I'd say, at least the last 10 years or so. So there's nothing in the code that prohibits it. When it comes to that part of child safety, we just have to rely on parents being parents and not letting their kids climb them. And, I know there's a lot of home inspectors who will kind of make a big deal about this. They'll say, oh, it's not allowable or you shouldn't do this. To me, I don't. I got to draw the line somewhere. And I know I blogged about this at one time, but my thought is, where do I stop when I talk to parents about child safety? Do I tell every person buying a house with a stairway that, hey,
stairways are extremely dangerous. If you've got little kids, you shouldn't let them fall down the stairs or play around them. It's like, no, this is going nuts. So that isn't something that we talk about during home inspections. I'll let parents figure that one out on their own.
You don't even mention it?
I really don't. I mean, if I was doing an inspection and parents brought their kids along and I saw a kid start climbing, I might say, hey, your kids might want to keep climbing this. Maybe you want to change this out or put some plexiglass or something or some, snow fencing in front of it for a few years. It's going to look hideous, but maybe you want to do something for a couple of years till your kids get older. That's as far as I go, but I wouldn't even put it in my inspection report.
Gotcha.
I don't consider it a defect.
Have you ever been at a party or something where a bunch of people leaned against a guardrail and the thing gave way and there was this whole mass of humanity heading towards the ground?
Well, not personally, but my old neighbor, that did happen to him. He had a big party there and his nephew or something was leaning up against it and just about went off the edge of the deck. The whole thing just collapsed on him.
Really?
Oh my gosh.
He was like 18 or something. He was nimble enough to where he didn't go over with the rest of it. But yeah, it happened on my next door neighbor's deck. And he ended up replacing his guards with exactly what you're talking about, those cable rails. And they look really nice. I mean, I really like them. That might be what I end up redoing mine with.
Well, you've been at this a long time. So have you ever been called out to do like an inspection after a deck fell or collapsed off a house?
No, I think that's beyond my pay grade. I'd leave that up to the engineers and the lawyers.
So why would a deck just fall off the side of a house?
That's a great question, Bill. Well, at that attachment point that Reuben was kind of describing before, the ledger board, it's really important to make sure that ledger board is attached to the house properly. That's one of the key areas to inspect. And so there's a few different ways of making sure it's attached properly. But some ways that you shouldn't attach it, first of all, would be with just nails. And we see that a lot out here, at least in Minnesota, where it's, nails going through the ledger board into the house, into the rim joist. And that's not an approved attachment method. So we never want to see that. But there's a few different methods. And actually, Reuben, I'm going to give a shout out to your blog right now because you've got a really great blog about decks and common defects on decks, right? And you just redid that?
Yeah. And the intended audience for this is homeowners. This is supposed to be how to inspect your own deck. And I've published it already. I redid it and I published this on May 4th of this year. So if you go to our website and you go to the blog, we'll have a link to it in the show notes too.
Yeah.
But if you go to our website, you can see tons of photos and everything Tessa is about to describe. We'll have lots of good visuals for you.
Yeah. So one attachment method would be lag screws. And lag screws take a little bit of work because you got to pre-drill through the ledger board into the rim joist of the house and then kind of drill again that hole through the ledger board and install that lag screw, 1/2-inch lag screw. So that's one option. Another option would be to use like carriage bolts, or another name is through bolts through the house, 1/2-inch.
Well, you said carriage bolts, although we will talk on carriage bolts and why you shouldn't use carriage bolts anymore. But
yes. Okay. Through bolts are okay. Do you have to pre-drill with those?
Yeah, well, that's just machine thread.
Okay.
Yeah.
All right.
So there's nothing on that bolt to get through the wood.
Wow. Okay. The most common one I think that I see now would just be these special screws that are designed for this attachment at the ledger. And what are they called? Just ledger screws, special ledger screws?
I suppose that's what I'd call it. Yeah.
Okay.
There's two big manufacturers that make them. You've got Simpson Strong Tie. They make one, and then Fasten Master makes one. Fasten Master, I know they call it a ledger lock screw.
Ledger lock.
And lock is LOK.
Does that provide both to the house support and support on the weight, like downward pressure?
You know what? That's a great question, Bill. And you're talking about vertical loads and lateral loads, two different things. And all of these attachment methods that Tessa has been talking about in the past, we've kind of relied on all of these to do both. We've relied on all these fasteners for downward support and outward support on your deck. And it's worked mostly well on most decks for a long time, but back when we updated the state building code for Minnesota in 2015, there was a whole section that got added to the code telling you exactly, well, not exactly, but giving you a lot more detail than we used to have on how to build a deck. And they actually had a new section on there saying you, in addition to the traditional fasteners, you need to account for lateral loads. And they gave one idea of how to do this. They said you can use these two special fasteners that are just about impossible to install. Each fastener is supposed to hold up to 1,500 pounds of pressure for a total of 3,000 pounds. You put two of these in, and it's going to be this big hunk of metal that attaches to a joist on the outside, and then a big hunk of metal that attaches to the floor framing inside the house. And I don't mean the rim joist that goes around the outside of the house. I'm talking about the actual floor framing. So you need to have access to the finished, well, to the space inside your house. I mean, if it's finished, forget it. You can't do it. And even if you do have access, the manufacturers have really specific instructions on how the floor sheathing needs to be nailed to your floor joists.
Oh my gosh.
You need a special nailing pattern. And who in the world could ever verify that? So this is what the building code specifies, but I don't think anyone's ever actually done this before. Shortly after this requirement went into effect, we started seeing these new fasteners where you actually use 4 of them. Each one will support up to 750 pounds. And you use 4 of these, and they're pretty simple to install. It's a chunk of metal. You put a bunch of special structural rated screws into your floor joist of the deck, and then you put one big long fastener into the house. And the fastener isn't designed to go into the rim joist of the house. It's designed to go into the top plate of the house. It's a 2x4 or a couple of 2x4s that sit right on top of your foundation wall. So that's going to be really securely anchored to everything. So the fastener goes directly into there. So all this to say, since 2015, if you're looking at a newer deck, you should see at least 4 special fasteners designed for lateral loads. Sorry, long answer to your question, Bill, but there it is.
Thank you.
You know what? Okay. One other thing about ledger boards that doesn't have anything to do with like attachment to the house or strength that we should definitely mention though is flashing.
Ooh, yeah.
Really important component of a deck. So it's a piece of metal that, tucks up underneath siding and kind of comes out over top of that ledger board and basically protects any water from getting in between the deck ledger and the house and like getting into the wall. So decks that attach to the house, which is most decks that they're built that way, they're not freestanding, that's going to be a prime location for water entry into the wall because we've got all these penetrations. And so if you don't have that flashing, there's going to be a much greater chance of having water intrusion at the wall, which can be really problematic, not only in terms of just rot and mold and, degradation materials, but in terms of just like strength of the deck and the attachment to the house, and it can cause failure too. So that's one thing that we always look for when we're inspecting decks.
Bad news when water gets in there.
For sure.
And then, as long as we're talking about the attachment to the house, just one other thing that we look out for is if you have some type of bump out on your house, like you've got a bay window or something like that, where there is no foundation directly below a section of your house, you're not supposed to attach a deck to that because you don't have any way of transferring that load directly to the ground. It's basically like you've got a little bit of your house cantilevered out from the rest of the foundation, and it's not designed for the additional load of a deck. So when you see a deck attached to a cantilevered part of the house, that's a no-no. The only way you can properly have a deck when you got a cantilever is they need to add a bunch of extra framing in there and essentially header it off. You need to transfer that load to something else that goes down directly to the earth. And I'm not going to try to use a whole bunch of words to describe it. It helps if you look at a picture of it. I've got a picture of it on my blog post where we discuss this a little bit, a nice diagram of what that would look like. Something else that came up in a class that I sat through recently is that even if you do that, this additional framing can't be supported by your deck ledger board. That ledger board that attaches to the house, you can't rely on that to support all of this additional weight because you're creating a point load. And they say you can't have a single point load on your ledger board. And we've seen this done dozens of times, probably hundreds of times collectively, where they take a special joist hanger, a special piece of metal, and they just fasten that right to the ledger board. But you can't do that. The only way to do it right would be to use a special hanger that's attached with bolts or big lag screws or some other type of special fastener that goes through the ledger board into the rim joist of the house. That's really the only way to do it. So it's really easy to get that detail wrong when you've got a cantilever at your house.
Reuben, what would you say is the best solution? And I know as home inspectors, we're not, giving advice on how to repair certain things, but what are some options if you do have like a cantilever? How do you fix that?
Tess, probably the easiest way would be to header it off. You put some type of beam in there that all of your joists are going to attach to, or you put it underneath your joist if you got room for it, and you have it independently supported with a couple of posts. You put a post at each end, but it gets tricky because every post is supposed to be supported by a footing, something that's going to transfer that load down to the earth. It's usually we use just a big chunk of concrete. People usually dig a big post hole and they fill it in with concrete. Maybe you use a form, and then you put your post on that chunk of concrete. And it's important that it goes all the way down below the frost line. Here in the lower half of Minnesota, we say that you need to go down 3.5 feet, 42 inches. It needs to go down at least that far to help prevent frost heave. And we just keep going deeper and deeper. We're peeling back layers of an onion. And now I realize I'm into a different topic, Bill. I'll bring it back. But
yeah, please do.
I will, but we got to talk about frost heave for a second, because, I live in Maple Grove and we've got some pretty clayey soil. And yes, clayey is a word. Look it up. We got some very clayey soil, and it's expansive soil. When it gets wet, it wants to expand. And in the wintertime, when that's really wet and it freezes, it heaves, it rises up. And it can actually grab that footing and raise the footing up. And then the soils will settle back down and they'll fill in underneath the footing. And over time, it'll just keep pushing that footing out of the ground. I had another neighbor who had frost. This is called frost heave. I had another neighbor who had frost heave so bad at their house that their deck was starting to rip away from the house. And it was starting to destroy the floors right inside their patio door.
Oh my gosh.
Yeah, it was messing up their house badly.
Wow.
And,
at that point, you want that leisure attachment to be somewhat less than durable.
Exactly. That'd be a situation where you don't want it attached quite so well. And you'll drive around and you'll see some decks where it's like you'll have sections that just go way up or way down and they're totally wonky. That's probably the result of frost heave. So it's a challenge to get away from that. It's part of the reason that footings need to go down at least 42 inches. But even if you do the code minimum of 42 inches, it doesn't mean that there's a guarantee that you're not going to have problems. There's a dividing line in Minnesota where it divides the southern half from the northern half. And in the northern half, you actually need to go down 5 feet. So,
oh, wow.
So it's like, all right, what if you're right on the border? You're 10 miles south of this requirement. Does that mean that the cold is going to know to not come into your neighborhood?
Split the difference, do 4 feet.
Yeah, it all comes down to the code is the minimum. You need to do at least 42 inches, but it doesn't mean you're not going to have problems. So anyway, Bill, you need to have posts to support this thing. You need to have footings for those posts, and those footings need to sit on undisturbed soil. Let you think about that for a second. Undisturbed soil. It means soil that has been able to compact itself for decades and decades, and it's not going to settle. It's going to stay right where it is. If you're going to put a couple of posts right next to your house, well, when that house is built, they dig a big hole in the ground and they put the foundation in and they backfill. So that is not virgin soil. It's not undisturbed soil right next to your house. It's soil that is not going to support the weight of those footings. Would be to dig all the way down so you're at the same depth as the footing for the rest of your house. Or you could do some type of special footings or special posts. One way would be something called a helical pier. And that's where it's basically, picture a gigantic screw with a big steel rod attached to it. When I say gigantic, I mean the threads on this thing might be 6 inches, 8 inches in diameter. And they'll have this special machine that I believe is attached to a bobcat, and they basically screw this thing in. I think it's like a gigantic impact driver essentially, and they keep going down into the ground until they can't turn that screw anymore, until it reaches a certain psi, and then they say, all right, that's enough, we're done. It's going to bear enough weight. You're essentially going to have a steel footing, and then you can attach a wooden post to it. That's probably the best way of dealing with this. I know it's a long and complicated answer, but this goes into why we as home inspectors don't design repairs.
Mm-hmm. It's complicated.
Yes. Decks are complicated, man.
Can we circle back to this cantilever conversation?
Yeah.
Because we were at a friend's house at a cabin once. We were all just looking at the neighbor's deck, and the cantilever, the amount of deck that projected past the last supporting beam or post, or it was almost equal to the amount going back to the house. So you can imagine there was this like teeter-totter fulcrum right in the middle of this cantilever deck, and we were just shaking our head. We're like, well, if you put about 500 pounds on the other side, that thing might just catapult you right down into the lake.
Oh my goodness, that's scary.
What are the requirements if you're going to cantilever beyond support? What are the requirements for that?
Isn't it 1/4 the length of that joist can extend beyond the beam
exactly
or support?
Yep. So it means that if you've got 10, well, I'll try to make the math easy.
Yeah.
If
something that's easily divisible by 4. Let's do that.
Yeah, let's say you've got a 12-foot joist coming out from the house. You could have it coming out 9 feet. You could have your beam, and then it could extend another 3 feet out. Or wait, did I get that wrong? I got it wrong, Tess. I think it might be for 4 parts on the inside, you can go 1 part outside.
Oh.
Right. I know it's 1 to 4. I could say that much definitively.
Yeah.
Okay.
Well, I was going to say, I mean, decks are complicated. And one thing that comes up a lot too is like, what's an okay span for this joist? And like, I don't have that memorized, but there's a span chart in the Wood Council's deck construction guide.
Yeah.
That has all the allowable spans for different types of wood in different dimensions. So that's a great place to look.
Yeah, and that's a great document. I mean, if you're gonna be inspecting decks or building decks, or you want to check out your own deck, get your hands on this book. We call it DCA 6 for short. It's like Tessa said, it's put out by the American Wood Council, and DCA stands for Design for Code Acceptance. And they wrote this book based on the national building codes, based on the International Residential Code. And it's a PDF to show you how to build a deck to meet building code, because the building code is kind of difficult to understand. So they've got lots of diagrams and illustrations and lots of extra text to really interpret what the code means. And they've got a nice span chart in there, and it mirrors what the building code says, but it's probably a little easier to read their book. If you do a Google search for DCA 6, it'll be the first thing you find. It's really easy to find it.
Sounds like a document that should be hanging at every big box store next to the treated lumber. So, so a bunch of weekend workers can decide how thick do we need to build this framing?
If only the type of people that were just ready to go out and build a deck with no experience were the type of people that would stop and read directions. They're probably not.
I take a lot of flack for throwing directions away at my house. Okay, so anything else that you guys look at closely when you're inspecting decks? Feels like stairs might be an issue. Do you see stairs?
Yeah, I mean, we've got the stairway attachment to the deck. We've got the posts. We've got beam post connections. We've got joists and how they're attached to the beam and to the ledger. There's all these attachment points that we need to look at closely. So, gosh, where do we start? Stairway attachment to the deck is really important. And Reuben, correct me if I'm wrong, there's nothing in the Minnesota State Building Code that specifies how that needs to be attached. But yeah, okay, but in the DCA 6 or the Prescriptive Residential Wood Deck Construction Guide, they do have some recommendations for how to do that. And they show some different brackets basically to use that, attach the stringer to the deck. But a lot of the times you'll see improper brackets used or no brackets, or people just use nails to attach it. So that's one area that we look closely at for sure.
In my blog post we referred to, I just had a little fun and I pulled up some photos of improperly attached stairways. And I found our top 30 improperly attached stairways and I put them in here. It's probably way too many, but it helps you understand that there's a gazillion ways to get this wrong.
Yeah, for sure. You know, it's crazy. You know, some of these pictures are even from new construction houses that we've inspected, right? That have been built by, well, contractors, and then I guess they're subcontractors. But, you know, just because you've got a deck that's been built by quote unquote professionals doesn't mean that it was done properly.
Well, people, don't look at your decks. Sometimes it could get depressing because when you were blissfully ignorant about how poorly it was put together and you had your 12 best friends on the deck, you're just having a good time. But if you go underneath and you look up and you're like, oh my, now you can't have your parties anymore. All right. How do you guys feel? It's been 2 weeks of technical talking. Are you getting your technical groove back on?
It's better.
The technical groove. Yeah, it's back. You know, one thing I just want to add about the deck stuff, which, you know, we kind of zoomed in and started talking about all these connection points and types of, you know, fasteners and all that stuff. But I think when it comes to decks, like the most important thing to keep in mind when you're inspecting it is take a look at it from a distance. Like, don't forget to take a wide loop around and get some perspective views on it, because that can be really helpful in putting some pieces together. And I remember, Reuben, you've got some pictures of this crazy deck in one of your CE classes for real estate agents that you teach about defects in new construction. I remember you show this picture of a deck from a distance, and in that distant shot, you can see how the beam that the joists are resting on is like sagging, and how there's not enough posts to support it. And one thing that's easy to do if you're inspecting and you're just kind of walking underneath the deck is to miss stuff like that. You know, you may not notice that there's that sag. And so it's really important to take that wide look around. And in the same class, Reuben, I think it was even the same deck. This person that built the deck had post supports in the wrong location, right?
Oh my goodness. Yes.
Describe what was going on with that deck.
Well, they had a whole bunch of joists attached to a beam, but instead of putting posts underneath the beam, they put the posts underneath two different joists. So
oh, no.
we're relying on the connections from two joists to support all of the other joists. And, you know,
Wow.
it goes back to Bill's question at the beginning. He was saying, what's the craziest stuff you see that makes you scratch your head? And for me, it's where people don't think through the load paths. The load of the deck is not transferred down to the ground. That's the one that always just makes me scratch my head. And it's tough to talk about on a podcast. It's almost like you got to see photos. I'm inspired now. I'm going to post a top 10 crazy load paths on decks.
Yes.
As a follow-up to this one. That'll be a good one. Maybe it'll be out before this podcast, so you'll be able to look at it.
Where does everybody find this post, Reuben?
StructureTech.com, and you go right at the top and you click on blogs, and it'll be a couple of the most recent blog posts in there.
Okay. Well, I think that puts a bow on this conversation. We'll be back next time with more technical conversation. You've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Reuben Saltzman. Thanks for listening. We will catch you next time.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.